wind up doing is starting with the newer parts of 6-4, things that you haven't quite seen yet, and then build into some of the things you guys have done in the past starting tomorrow. I know there's some people that will be gone on the field trips and whatnot for tomorrow. We'll build into this between 6-4, like the first part today, tomorrow, and we'll probably try to tie it all together into Friday for that last 25 minutes, whatever those little periods are then. So we'll be doing this for the next few days. So let me start with this question. When we did stuff like this, and I asked you to factor it, if I asked you to factor that, we called that what? Do you remember?
Difference of squares.
Difference of squares. And you would tell me that my two terms when I factored it would be what and what?
X plus 2, X minus 2.
Okay. Could we have done it like this?
No.
No, we could not factor it like that, correct? So what we're going to do today is we're going to take it a step further, and we're going to, instead of working with differences of squares, we're going to look at difference of cubes.
So much harder to identify cubes.
Not really, because what's going to happen here is you're going to have to look at, there's going to be a pattern for these, okay? And in order to work with the patterns, you're right, you're going to have to identify perfect cubes. Well, perfect cubes, cube roots, they're a lot easier than you think. 8, what's the cube root of 8?
2.
What's the cube root of 27?
9.
3. What's the cube root of 64?
4.
What's the cube root of 125?
5.
What's the cube root of 216?
6.
So it's not that bad.
You were just going in chronological order.
To be honest with you, those are going to be the largest values that you have to really know. Really, in essence, I mean, if you start getting any larger than that, you'll have a calculator at some point. But if I give you stuff that's not going to have a calculator, I don't know them over 6. I think 7. I know 7 ends in a 3. 343. Is it 343?
Yeah, we did it the other day.
Oh, okay. Look at that.
Yeah.
So other than that, I mean, it's just a matter of getting accustomed to what the pattern looks like. So when you have a difference of cubes, we can actually do it as a difference of cubes or a sum of cubes. And that's what we're working with today. Sums and difference of cubes. So let's look at the pattern. The pattern for these works out to be the following. Oh, if I didn't put these in the order, I would. Oh well. We wind up with these two patterns. And I'm going to write them up on the board here as well. We have two patterns for sums and differences. First term's a perfect cube plus the second term's a perfect cube. When you factor it, a plus b, a squared minus ab plus b squared. Now let me just walk you through what just that first one looks like with numerical value. Okay. Let's use the example of the x cubed plus 8. Don't worry about this one yet. Don't worry. I'm going to hide it from you. You can't see it. Nothing to see here. All is well. Pay no attention to the man behind the counter. Yeah, that's it.
I think I can see that.
Now, when you're looking at this, is x cubed a perfect cube?
Yes.
Is 8 a perfect cube?
Yes.
Once you go through those two things, what you wind up doing now is that your x cubed is playing the role of a cubed, and 8 is playing the role of b cubed. So therefore, what's a and b?
A is X.
Yeah, x and 2, okay? So to factor this, you take the cube root of both of them, x plus 2, and now it's just a matter of putting it into a trinomial. Square the first one, square the last one, multiply the two of them together in the middle. And change your signs. Yeah, multiply the a and b together. Works every time. One thing you just have to be careful with are your signs. Okay. Now, when you have the a cubed minus b cubed, you get a minus b, a squared plus ab plus b squared. And I'm not going to lie to you. When I first learned these things, when I was in high school, I screwed up the signs all the time. And I had a hell of a time trying to remember which one was which and which signs went with where. Until I started to look at the pattern more and more and more. When you look at it, notice how you've got sum of cubes. The first thing in parentheses was positive. The next sign was negative. Positive. The last term is always positive in both of them, no matter what. The first term is the same sign of what you're working with. It's a sum of cubes. This one's a positive. It's a difference of cubes. This one's negative. The second one is always the opposite. You see that? It takes a little getting used to. If any of the material that you work with on these, that's the stuff you're going to screw up. It's just figuring what signs to work with. Okay? It's just a matter of practice. It's just a matter of getting used to how it works.
So at first you're the same, then you're positive.
First you're the same, then you switch it. I see what you're saying.
Last you're positive. So.
Yes, the last one will always be positive. That's a given. You will always do that. The last term will always be plus b squared. The first one will be the same. And I don't want to say second sign. I should say the second addition or subtraction. The sum. Because if you have a and b, those would be positive or negative. But you know, that addition, then the next one's subtraction. That's what I meant. Okay. Like I said, it's the same exact scenario if I'm working with a difference. So let's try x cubed minus 125. Is x cubed a perfect cube? Is 125 a perfect cube? Okay. So what's the cube root of x cubed? X. What's the cube root of 125? Is it going to be x minus 5 or x plus 5? It's minus 5. And now, square the first term, square the last term, and what goes in between the two? Is it plus 5x or minus 5x? Plus 5x. And last hour they were asking me if they could factor that second term any further. Can you? What times 1's 25? You have to go to get 5. Nothing. You're going to say what?
Wait, how do you get the 5x?
You're taking the A and B multiplying together.
Oh, it's like.
You take the A and B value multiply them together. Right. Now, what gets a little bit weird though is if sometimes you have something that looks like this. 8x cubed is your first term. Yes, sir.
That last one, isn't it a perfect square, so we can pull it apart?
You can't. You can't do that on that last one because it's a what times what's 25 to add together to get 5. If it was a 10, yes, but it wouldn't work. Okay. So now, is 8x cubed a perfect square? Or excuse me, perfect cube? It is. What's the cube root of 8x cubed?
2x.
2x. Is 27 a perfect cube?
Yeah.
What is it? 3. So my a and b value here become 2x minus 3. So when I square my a value, what do I get? Good. Thank you for getting that right. You get 4x squared. Because your a value is 2x. And some of you guys were screwing that up earlier when we were taking the quantity something squared. Remember, you have to send that exponent to both terms within the parentheses as you square it. Okay? That's usually where people will mess up. So if the first term was 2x, I square it, I get 4x squared. My last term is 3. When I square it, what do you get?
9.
So it'll be a plus 9 here. And now I take the a and the b value and multiply them together. What do you get?
6x.
Is it plus 6x or minus?
Plus.
And you're done. Okay? Not so scary, is it? Until. Let's see here. Is 54 a perfect cube?
No.
Is 16 a perfect cube?
No.
Do you have to like turn it into
Can you?
Oh, it's the
Divide it one by 4.
Hold on. If you divide it by 4, now here's, I like what you guys are thinking. If you factor out a 4, you get 9x cubed, and 4 are divided by 2. If you divide them both by 2 and you factor out a 2, you get 27x cubed plus 8. You see? Okay, are
Can't you
you?
just get rid of it?
Oh, I'm just about to ask this. Am I setting this equal to 0?
No.
No. So I'm just factoring it. So does that 2 go away?
No. No.
No.
You done messed up.
Yeah, you done messed up. You don't get rid of that 2 value because all we're doing here, guys, is factoring right now. The minute that we set something equal to 0, that's when you can start alleviating some of those GCF issues, where you can get rid of the constant. Since we're just factoring, we cannot do that. So now, is 27x cubed a perfect cube?
Yes.
Is 8 a perfect cube? All right, you were saying? So you bring the 2 with, so it's 2 times the quantity, 3x plus 2. Now what goes in here?
9x squared, 6x minus 6x.
Good.
Plus 4.
And you're done. Okay. Every once in a while, you might have to factor out some constant to make it work. When you go through the cubes, I don't think any of the numbers that I'm working with to get you guys, I don't think it gets any larger than 6. I really don't. Like 216 might be the largest perfect cube that I hope you remember off the top of your head.
216 is
6, yeah.
5 is 125. And 4 is 64.
So, try both of those. I want to see if you can do that part B. I haven't shown you yet. See if you can do it.
Wait, so do A too?
Yeah, do both of those real quick. See if you can figure it out. I'm gonna give you a chance to see if you can figure out B. All right. Let's see. The first one I'm guessing was pretty simple. X plus 3, x squared minus 3x plus 9. Okay. The second one. What's your first rule of factoring? In this case, the easiest thing to take out would be a
2u squared.
Oh, that's
So I'm not saying it.
What you're doing here, in the past, you guys were trying to create perfect squares or things like that, the difference of squares by factoring out certain values. Here, you're looking to create a perfect cube. It's something new, it's something different, you haven't done it before, so it just takes a little getting used to. This 2u has to go along for the 2u squared has to go along for the ride. We went it with 2u minus 5, 4u squared plus 10u plus 25.
I didn't turn up.
What direction is this going? The graph.
It's gonna be.
This is exponent.
Wait.
Positive exponent?
Yeah, because it would be. Is it
Positive exponent or positive odd, positive value, odd exponent. You always look at that one, test the degree, yes sir.
I'm sorry.
You better be. I'm joking.
Why do you look at over there?
Thought it
That
was-
I said it, but I
Let's see, it's page. I want you to do 8 of these, please.
Oh, that's too many for me.
Well, I know. You'll be
I don't
okay.
even know if I can count this.
Hey, Allie.
Good luck.
Guys, so you know, I said it's gonna say because you don't have to do work stuff? Yeah, man. Wait, what did you?
I was supposed to go to that last night, but I felt bad. I seriously fell asleep, and I didn't make it to it.
It wasn't
I know.
anything impressive anyway.
I got a whole bunch of orchestra and I totally forgot. I didn't mean to. It just